Hello everyone! In this lesson, we will learn Section 3 of Chapter 6, Selection of Ventilation Equipment. Tunnel ventilation equipment mainly includes ventilator and its motor. In terms of equipment selection, the ventilator must be selected first and then the motor. Requirements for tunnel ventilation equipment. 1. The tunnel must be equipped with two sets of main fan devices with the same capacity, one of which is for standby. The standby fan must be able to start within 10 minutes. 2. The service life of the ventilator shall meet the first level ventilation requirements as far as possible, and the second level ventilation shall be properly taken care of. Within the service life of the ventilator, its working point shall be within the reasonable working range. 3. A certain margin shall be reserved for the capacity of the fan. When the actual flow fan is under the maximum design negative pressure and air volume, the operating angle of the impeller shall be 5 degrees less than the allowable range. The type selection design speed of centrifugal fan shall not be greater than 90% of the allowable maximum speed. 4. When the height difference between the inlet and outlet shafts is more than 150 meters, or the elevation of the inlet and outlet shafts is the same, but the valve depth is more than 400 meters, the natural wind pressure should be calculated. 5. For short tunnels, only ventilation requirements in difficulty periods are generally considered. 6. The tunnel must adopt mechanical ventilation. The main ventilator must be installed on the ground. The valve head equipped with ventilator must be sealed tightly, and the external air leakage rate shall not exceed 5% without lifting equipment and 15% with lifting equipment. The basic data necessary for model selection include working model of ventilator, press in or draw out, gas grade of tunnel, air volume of tunnel in different periods, the maximum resistance and the minimum resistance within the service life of the fan. The calculation formula of fan air volume is as follows, where QF is working air volume of main fan, QM is tunnel air demand, K is air leakage loss coefficient taken as 1.1 when the air shaft is not lifted, 1.15 when the skip shaft is also used as return air, 1.2 for return air and lifting personnel. The calculation formula of fan air pressure is as follows, where HM is total resistance of ventilation system, HD is resistance of auxiliary devices of fan, HVD is kinetic energy loss and diffuser outlet, HN is natural air pressure when the natural air pressure and the fan air pressure have the same effect, taken plus. When the natural air pressure and the negative pressure of the fan are reversed, it is taken as minus. Primary selection ventilator. According to the calculated QF, HSD minimum or HTD minimum of the ventilator in the easy period of main ventilation, and QF, HSD maximum or HTD maximum of the ventilator in the difficulty period of tunnel ventilation. The ventilator meeting the requirements of tunnel ventilation is selected on the characteristics curve of the ventilator. Because the operating point is determined according to QF, HSD minimum or HTD minimum, and QF, HSD maximum or HTD maximum, the design operating point may not be exactly on the characteristic curve of the selected fan, and the actual operating point must be determined according to the working resistance of the fan. Calculation steps 1. Calculate the working mean resistance of the fan when static pressure characteristic curve is used. The calculation formula is as follows. When the total pressure characteristic curve is used, the calculation formula is as follows. Calculation steps 2. Determine the actual operating point of the fan. As shown in the figure, the working wind resistance curve of the fan is drawn on the characteristic curve of the fan, and the intersection point with the wind pressure curve is the actual working point. Determine the model and speed of the fan. According to the working condition parameters QF, HSD, EAT, N, compare the technology, economy, and safety of the primary fan, and finally determine the model and speed of the fan. Motor selection. The input power of the fan is calculated according to the easy and difficult periods of ventilation, and the input power N minimum and N maximum required by the wind are calculated, respectively. The calculation formula is as follows. Working mode and installation location of mean ventilator. For the extraction ventilation system, as shown in the figure, the mean fan is installed at return air wellhead. Under the action of the extraction type mean fan, the whole tunnel ventilation system is in a negative pressure state lower than the local atmospheric pressure. When the mean fan stops running for some reason, the pressure of the underground airflow increases, which is relatively safe. As for the press-in ventilation system, as shown in the figure, the mean fan is installed at the air inlet wellhead. Under the action of the press-in mean fan, the whole tunnel ventilation system is in a positive pressure state higher than the local atmospheric pressure. When the caving fissure reaches the ground, the harmful gas in the tunnel air of the pressure ventilation mine leaks out through the collapse area. When the mean fan stops running for some reason, the pressure of the underground airflow decreases. For the mixed ventilation system, as shown in the figure, a fan is set at the air inlet wellhead for press-in operation, and a fan is set at the air return wellhead for extraction operation. The air inlet part of the ventilation system is at positive pressure. The air return part is at negative pressure, and the working phase is roughly in the middle. The positive pressure or negative pressure is not large, and the air leakage from the gulf to the surface is small. Its disadvantage is that it uses a large number of fans and complicated management. Let's summarize the knowledge points learned in this chapter. In this chapter, we learned the types and selection of tunnel ventilation systems, calculation of total air volume of tunnel, calculation of tunnel ventilation resistance, working mode and installation location of mean ventilator, tunnel ventilation design method.